Okay, well, let's do this. So, you've heard the talk from Jingwei just before me, and she was looking at test tools from an Office perspective. And then prior to that, there was a talk that covered test tools, but from a Windows perspective. This is test tools with a SQL Server slant. And a lot of the information is going to be similar. So rather than going to too much detail and end up repeating stuff you've already heard, so I've got two goals with my approach. I will show you information that is familiar because of the two prior talks, but it's a way of reinforcing what you've heard. And if you're new to protocol testing, it'll be a way for you to see the overall architecture below which the deep dives that you saw, was happening. So hopefully it won't be too boring. You can learn something from it, and if you don't think it was a good use of your time, hey, that's why we have surveys. So at the end of the talk, you can fill out the form and then let us know. All right, well, let's try this. So, oh wait, no wonder everything's so fuzzy. I've got the wrong glasses on. It's all your fault. All righty. Yeah, that's better. Okay, so the agenda here loosely is I'm going to start with a fairly high-level look at two of the tools that we share with Windows and Office, and there will be the SQL Server parsers, well, parsers in general that you would use with a message analyzer for testing, and then I'll look at test suites from a similarly high level. And what I mean by a similarly high level is I'm going to look at the architecture, the design, and as far as the two remaining test tools, OData Validator and the Model First tool, I go into a little bit more detail. So it won't be the 10,000 foot level that I do with the first two. I'll come down a little lower because these tools have a stronger significance when it comes to testing SQL Server protocols. They focus on OData and RESTful APIs. So let's get started, starting with the SQL Server parsers. It won't be too different from what you've already heard from Jingwei. So parsers, well, there are two main categories of tests when we're looking at parsers. You've got the unit tests where you're looking at simple verification of, say, a statement in the protocol specification. And then the scenario test is where you have a scenario, say you've got a client talking to a SQL Server database, it's retrieving information. When the information gets back, you configure something or the other, send it back to the, say, the analysis server. And then you get another response back. That's an entire scenario. So we test using parsers and message analyzer. You can test an entire scenario, or you can just pluck one of those tasks out of that whole scenario and then test it using a unit test. And the idea behind testing with parsers and message analyzer is to have 100% coverage of the information specified in the protocol. And that helps you determine whether or not your design or your implementation, conforms to what's outlined in the protocol document. You can download parsers from that site, but the current collection of parsers is being refreshed. So if you were to go to this location right now, you wouldn't see the updated protocols which match, the updated parsers which match the refinements that have happened in the SQL Server protocols. But that's currently being refreshed. That's as in the list is currently being refreshed. So hopefully very soon we will have an up-to-date list, and you can start trying out, some of the tips and tricks you heard over here in the at the Plugfest. So parsers, yes, we use them. We use message analyzer as well, just like Windows and Office when we're testing protocols. The other test tool we use, or the other testing approach we use, is to use test suites. And well, you heard a lot of detail from Jingwei's presentation about test suites and how you configure the setup and all that. I'm simply going to do a quick run through of how the test suites are put together, Any developers in the room? Oh, okay. So, well, it wasn't a waste of time then. The idea behind me doing this is to give the developers an idea of how this tool that you're using was put together. It helps to answer some questions about, well, how do I know that this verification is 100% accurate? Or, what if I want to extend the test suite? How do I go about it? How was it put together in the first place? So that's the idea behind my looking at the test suite this way. So originally developed for testing internally, but it was then um, made available to everybody so you can test the implementations of the protocols that you're using, as long as those implementations are based on Microsoft Open specifications. So if those implementations are based on the documents that you find on our Microsoft Open specifications website where we've got our technical documents, then yes, you can use the test suites to confirm your implementations. So how do we put them together? Well, you go through the specification and you look for sentences that conclude include the may, must, should, or may not, must not, should not. And those give you a list of what we call requirements. What are the requirements that will let you know whether or not this particular behavior is what is outlined in the specification? Those are what we call the requirements. And the way you put the requirements together is you go through the protocol, look for sentences that include those keywords. Well, okay, so you've got a whole bunch of requirements. You put them into an Excel spreadsheet, as Jingwei pointed out. Then what? Well, you look at them and try and figure out whether or not they will be easy to test. That's a little difficult to explain, but you could, if you're interested, just come see me after the talk, and then I can try and come up with some examples. So you simply analyze your list of requirements and then pick out the ones that you think would be easy to test, verify. They become requirements. They become test cases. The related test cases, as I pointed out, you can group a bunch of test cases together to form a scenario. So after your list of requirements, you select the ones that can be turned into test cases. You look at the test cases and then come up with a logical grouping for the test cases. And they become scenarios which you can then test using message analyzer and a suitable parser. All right, so the collection of scenarios, you then add test modules called adapters. And that's what Jingwei was talking about. There are two types of adapters. You've got one that is used for configuring, initializing the connection between the client and the server under test or system under test, or the SUT. And then once you've configured, it also does a lot of work behind the scenes to maintain the connection between the client and the SUT. And the other adapter that you develop is the adapter that does the actual communication using the protocol for which you're running the tests. Okay, so what all that looks like when you've got it up and set up and running is you've got your test suite, which is made up of the two types of adapter. You've got your test cases, which you put together after reading the documentation and doing your due diligence, making a list of all the may and must should occurrences, and then grouping them logically and all that good stuff. You then go through the setup and deployment instructions. As Jingwei pointed out, you end up with a whole bunch of folders. There's a deployment guide in one of the folders. There's a README, and then there are setup instructions. You go through all that. Your system is set up. You have your system under test configured, and then obviously the next thing you do is you go on then. Oh, there we go. You run your test cases against the system under test. You eventually come up with results, and you have three different. Oh, sorry, I thought somebody. You end up with three different types of log files. The TRX log file is generated by Visual Studio, and it has an entire listing of all the test cases that were run, regardless of which scenario they were a part of. It's just looking at the raw number of test cases. So you might end up with 273 test cases, which match maybe 95 scenarios. So the TRX gives you the name of the test case and then a pass or fail. You also have an HTML file, which is generated as part of the test process. And that has information about the scenarios. And once again, you have pass-fail indications against the scenarios that you were testing. The XML file, I should have listed them the other way around. So it should have been TRX, HTML, XML. The XML file may or may not be generated. And I say that because it's generated by the protocol test framework, the PTF. It's the framework that is leveraged in creating test suites, especially for Windows and Office. If you're developing a test suite for SQL Server, it may not be generated, and I say may not be because if you're testing a SQL Server protocol which ships with Windows, then yes, it is fairly likely that the XML file will be generated because you're using the protocol test framework. You can use the protocol test framework to create a test suite for SQL Server. I don't know if that is necessarily the typical way to go. And if somebody's interested, I can check with the team in China that works with us, and then I'll provide the information. Actually, the slide decks are all available after the talks, so I will add an addendum or an appendix or something to this, and then put all this information in there just in case somebody needs it. All right, so XML file has some additional information, and that's generated by the protocol test framework, but it's related to the tests and the scenarios, and of course there'll be information about, pass or fail and errors and warnings and stuff like that. All right, so you've got your system under test, you've fired test cases against it, you got your results, you analyze the results, and then what you do is obviously match the behavior, or rather compare the behavior with what's in the protocol document, and then you make up your mind about whether or not your implementation is according to what's laid out. If not, you do your usual debugging, troubleshooting, try and figure out what went wrong, read the warnings, and then take it from there and just iterate through that process until you get the results you're looking for, and you're good to go. So that's a high-level look first at parsers that you would use with a message analyzer, and now test suites. And we are going to take a closer look at two of the tools that are used when you're testing SQL Server protocols. And as I said, these tools I will give a slightly closer look at because of the fact that they typically test OData. So the way in which I'm going to do the closer look is I'll start with an intro to the tool. We'll look at the design, the architecture behind it, and then I'll do a demo, fingers crossed, just to give you a look at the live tool. So when you go to the website where the tool is hosted, oh, by the way, the tools are all open source. You can get them on GitHub, download, install, improve on it, give us feedback. So we're working with you as partners on using and developing and improving these tools. So use, provide feedback. The whole idea is to make your life easier as implementers. So the more you use the tools and the more feedback you give us, the better the tools are going to be. So go for it. Yeah, they're all free. Download, use. Okay, let's start with the OData Validator tool. Overview. Well, OData, Open Data Protocol, it defines a set of best practices. And the whole idea of the OData Validator tool is to help you during the development process to make sure that you end up with something that conforms with the description, the architecture, the spec for designing RESTful APIs. Okay, so it's now become an industry standard because it was widely adopted. It was initially designed as a Microsoft protocol, but after wide acceptance and after some improvements, it was adopted by the industry, International Standards Organization, ISO. IEC also approved it. It's an OASIS standard, so when you follow these links, you go to the standard specs and you can read through at your leisure. All right, so overview. The architecture involves a setup similar to what you have in a network. You know, you have a client and a server. Client making requests, server honoring those requests by providing responses. But of course, we are talking about a spec and we are talking about a standard. So the communication has to happen in a certain way for us to say that, yes, it conforms to what's in the spec. All right, well, so this tool is used for validating server responses. So your client is asking for information from what we call an OData service. It's the server side of the OData setup, and the tool focuses on validating responses from the server. The spec provides information which you can then use to, let's see, I want to make this relevant to what's going to follow. Okay, so when the OData validator tool is given a request to pass on to the OData service, the tool has to know the format in which to send the information to the OData service so that the service responds in a way that conforms to the design. And the way the OData validator tool knows how to format the request you just made is by using rules that were loaded into the OData validator tool at design time. And those rules came from the spec, the OData spec, the standard. So you point the validator at whatever endpoint here being the OData service, whichever endpoint you want to test, and then you validate the responses that come back. And you can test different types of information depending on which stage of the development you've reached when you start doing your testing. Metadata document would simply be testing the setup and the structure that's used at the OData service end for hosting the information. So it's data about the data, essentially. All right, well, so you want to test an OData service. Exactly what are you doing? Well, let's say you've got your OData service represented here by this cylinder typically used to denote a database. And that's the OData service. Okay, well, and then it's got a client that's making requests against the OData service. And remember, OData is based on HTTP, and HTTP, or Hypertext Transfer Protocol, HTTP is familiar to a lot of computing devices. And I use that expression on purpose, and you'll see why. All right, so you've got your client making requests, and it's using HTTP as the base transport. OData service recognizes it, but of course HTTP has been extended here, which is why we don't simply say HTTP, we're talking about OData because of the extensions that have been added to it. Well, if HTTP is familiar and understood by a whole bunch of devices, that means you have a whole range of devices with which you can work as far as OData and apps that use OData. All right, so the first thing you should know is every OData service that is designed according to the spec has a metadata module. So the simplest request you can make against an OData service is, hey, show me your metadata. You're saying, give me information about the way your data is being stored. What's the hierarchy? What's the nesting? Which nodes are parent nodes? Which ones are child nodes? And where do I find information? It also gives information about the filters that you can use. All right, so you get your metadata, and then in addition to that, these are the scripting languages you can use for querying against the OData service. This is a list of some of the examples of what you can use when you're making your queries. So the get, put, post, delete that you're familiar with when it comes to HTTP were carried over. So the semantics include those. And it's been extended a little more, so you're not just saying get customers or customer that's at index level 4. You want to say customers at index level 4. Within that, if you've got a whole bunch of child nodes, you want specifically the child node called orders. How will you know there's even such a thing? Well, when you do the get for the metadata information, that will tell you the structure, what the names of the fields are, which node contains which, and all that. So that's where you get the information with which to then structure your queries. All right, and it goes even further. You can use filters. So you've gone all the way down to customers, but you want a specific customer. And once again, the metadata information lets you know, oh, there are a few Redmond occurrences, and you want to list all of them. This is a typical query you would use against the OData service. And then while you're doing all that, the OData validator tool is looking at the formatting, the syntax, semantics. It passes it on to the OData service. Response comes back. It then looks to see, was it formatted correctly? If not, it tells you, gives you a warning or an error or whatever. And I'll go to the live tool and point the live tool against a sample OData service, and then we'll look at the results that come back. And the test team in China that set it up for us, I didn't make them. I asked them to add some syntactical errors just so you can see what the error messages look like when they come back. So when you see error messages, it's not because we are pointing it at a sample data which has some boo-boos. That's on purpose because we want you to see good result, a warning, and an error. Okay, so why even use it? I mean, why don't you come up with your own way of testing? I mean, sure you can, but I mean, for convenience, you've got this, which is a fairly important part of the ecosystem, because we want everybody to be developing to the same standard, so that you end up with OData services which have the same high quality as far as performance and conformity. You can, as I pointed out in a previous slide, pointed at different types of targets. If you develop your OData service, say using version N, and then 18 months later you hear OData version N.1 has come out, you need to make some refinements to the OData service you already have. You don't have to update everything to match OData version N.1. When you go to the tool and you want to test for conformity, you can select the version of OData that you used when you set up your service, and it will test accordingly using rules that match that version of OData. So the tool also gives you the options of making some additional selections, and you'll see when we go to the live web UI, and then this should make a bit more sense. So this is the open source project location. You can play with it, see what you think, give us feedback. So the rules come from the spec, or the specs, I should say. Oasis hosts a version, and you follow these links, it will give you an idea of what we mean by the conformity of the OData service, the expected behavior, the things to look out for, how to test, and all that. Okay, well, the OData validator is actually quite complicated. I'm not going to go through and explain this, but because the slide is available after the talk, you can take your time to go over this, look at the spec, and using the spec and using this diagram, you should be able to piece together, how things work behind the scenes when you're using the OData validator tool. So I'm just going to move quickly to a similar diagram, but simplified, so you're looking at it from the operational level as opposed to the nuts and bolts. So you have your OData validator tool, you have your OData service, and you want to test your OData service because you're proud of what you've done, but before you go talk to your manager, you want to make sure that, you're going to see lots of green as opposed to reds and yellows, for errors and warnings. All right, so you come up with some sample validation requests, pass them through the OData validator tool, formats it, sends it to the service, service responds, OData validator decodes the response, and then gives it to you in a way that either makes you smile or makes you swear, thump the table, whichever works. So this is the operational level, operational look at the previous diagram, which is a little complicated. I just wanted to make sure that at the end of this part, where we're looking at the OData validated tool, you have a good idea of exactly what we mean when we say testing with the OData validated tool. Okay, so demo. Before I do the demo, let's see. You can use the tool. What's this weird echo? You can use the tool in many different ways. We are going to start, or rather, yeah, we're going to start with looking at how to validate a URI. And then after that, we switch to testing using direct input from a JSON script, which I put together. I've already tested these two and I got the expected results, so hopefully I'll be able to duplicate that for you. And there are other ways of using the tool, but in the interest of time, I'm not going to go into that. We'll focus on the first two. So let's look at the first. That is a sample service we're going to use. I will set that up here. Okay. Oh, data validator. Okay. I'm almost there. Sorry to keep you waiting. Now, here we go. For some reason, the mouse moves about 1/10 its original speed. The pointer, sorry, not the mouse. It takes a while to get it across the page. Okay, here we go. So this is the live tool, and we are going to test. You select your test mode by selecting one of these tabs. The first test we're going to do is to test a URI. We're going to point the OData validator tool, which is this guy, at this sample OData service. So once you've selected the tab, which corresponds to the fact that you're testing a URI, you then check, make sure if you want to make any of these selections over here. I will be honest, when I played around with this tool, we had Atom Publish or XML or JSON. Now I see we've got JSON minimum, JSON minimal, and JSON full. And once again, I can add explanations about these two in the appendix that I add to the slide deck, make that available to you. So apologies for not having that information right now. All right, the default selection is JSON minimal, so I'll just go with JSON minimal. And the OData service was set up using version 4.0, so I'll leave that as is. And click validate, and hopefully it's not going to choke on me. So it's got 32 results. Let's scroll down. Oh, it's still working. Okay, complete. So you look at the responses that came back, and then greens are obviously okay. They match the spec, and this is where you would go to see, okay, exactly what did I pass again? If you see a warning, once again, there's you're pointed to a portion of the spec where the expected behavior is not exactly what the OData validator tool was expecting. So that was a bit redundant. But you understand what I mean. And when you get an error message, obviously it's these two. You will see your red was a cross in it. Service must return service documents as Atom service documents. Oh boy. Okay. I think we need to work on the wording here. But so you click, and it should take you to the spec, to the particular section in the spec, section 22. And the information over here will help you do your debugging, so you can troubleshoot and figure out what didn't work, and how you can improve things, how you can correct things. So this is a live look at the tool. The scope of this talk is not to go into such detail, but I thought it would help so that when you start playing around with the tool, you're familiar with what it looks like, what to expect when you point it at a URI and then click validate. It helps when you're reading through the handbook or the manual if you've already watched somebody take you through the process. And as I said, if anybody's interested in this level of detail or even more detail than this, see me after the talk, and then we can try and set something up before you leave at the end of this week. So in addition to all the results that it returns, it also returns its title here, source. It's actually the metadata. This is what shows you the structure of the data that you are testing against. And you can collapse these if it's too much information and you want to focus on just one set of information. You can collapse these. And another thing you can do, which I will point at, for some reason it's there's a drop-down box which lets you look at only errors or only warnings or only the past results. Let's look at the results. Okay, so this is probably an improved version of the tool. So when you collapse the results node, it takes away the drop-down box. But this drop-down box lets you focus on just the errors, just the warnings, or errors and warnings, or everything. You can rerun if you feel that you should have received some better results because something that's being pointed out as a warning you've already fixed. You might be looking at cached data, cached results. So it's always helpful to click rerun if you're not convinced that what you're looking at is the most up-to-date information returned by the OData Validator tool. So that was a quick look at the OData Validator tool. I will go back to the presentation and we will look at the next tool a little closer, the model first tool. Okay. Okay, are we still in business? Pointer not working, that's not good. Okay. Let's come back here. Okay, go back into presentation mode. Let's see if the pointer works now. Here we go. All right, so the next thing we're going to do, so we're not going to look at the next tool. We're going to look at the same tool, but using direct input as opposed to pointing the OData validator at a URI. And what you do when you do direct input is you come up with JSON scripts, which based on the metadata information you got back from the OData validator tool, you know what's in the database you're looking at. So you come up with your JSON script, which says, hey, give me one of these, give me one of those, and while you're at it, I want to see product detail and references for blah, blah, blah. And you put all that together, select the appropriate tab, and then once again, you validate. So let's try that. Go back to actually, first of all, I'm going to grab this. Wow, I'm having so much fun with these tools here today. I am going to grab the JSON script and then feed it into the I was hoping to copy paste from the notes, but which is what I'm trying in the background here, but okay, let's do it the hardware. All right. Oh, guys, when you do the survey, please give me good marks. I am a good guy. I'm just, it's after lunch. My brain is slow, Well, that's fine. That's fine. My manager's not here. Oh, hi, Jim. Ouch. Okay. I still have a few minutes. I could turn this around, We'll see. Okay, so let's go back into presentation mode. Actually, you know what? Here, let's do this. All right, go back to the live tool. All right, this time I am going to select direct input. Okay, so geez, I didn't have to do all that. Anyway, so I've still got the script in here from some earlier testing that I did. So what I'm going to do now is, well, first of all, you make sure you've got the correct version of OData selected. And once again, we've got this minimal and full thing. Minimal is the default selection. I'll go with that. So you click validate, and it will look at oh, that was quick. It'll look at your JSON script, look at the request you're making, the formatting and everything. One of one rules executed and one error. Wow. Okay. Yeah. And once again, it gives you the source, and the source is what you used to communicate with the service to see if everything was working well. So let's see. Result. Okay, so that was expanded. I collapsed it, which means it made one check against one test case, and that one check did not go well. But once again, you go to the portion, it's the same section 22. I think the test team did that on purpose. As in, to make things simple, they just selected the same section and then created the errors from that section to give us an idea what the errors look like. So you just go to the spec and then troubleshoot from there based on the information that you find. All right, you can test conformance level, metadata validation, and service implementation. Those go into a bit more detail, and it won't be easy to explain by simply showing you, return results and everything. So I just focused on the URI and direct input because they're fairly straightforward to explain. All right, so now I'm going to look at the next tool, which is the model first tool. The model first tool allows you to use an API design approach which says, all right, I'm not going to do it the traditional way where somebody writes a spec and then we all get busy and we start coding against it. And then, oh, by the way, when the spec is stable enough, we can start testing, and you'll see what I mean. The traditional approach says, okay, we are going to have a PM write a spec, and then we're going to talk to a dev, and then the dev is going to say whether or not he or she can implement the spec. But before we get to all that, the Model First tool allows you to start by creating a model for what the end result is going to look like. And this tool, while you're creating your model, starts doing some work in the background to simplify the process for you. So the reason why this is helpful and the reason why it's being adopted by a lot of companies that develop APIs is it makes it possible to test as you design. So you do small incremental testing. It allows you to fail early and fail small. So you don't pound out 1,000 lines of code and then spend 2.5 weeks trying to figure out what the heck the first section actually does because you can't remember anymore. It's a little at a time. You fail, you correct, you fail, you correct. And by the time you get to the end, you've got a fairly solid design, a fairly solid model. And then you can do some real testing of the overall structure. The other thing is this tool generates documentation as you're creating your model. So when you're done, you're not going to have to pound on the door repeatedly for the dev to write the spec that matches the code that they've written. No, the tool generated it as he or she was working, so it simplifies things quite a bit. All right, so here's the traditional approach where you have at Microsoft, it would be a PM who would write the spec. At your companies, it could be somebody else. PM writes a spec, and then they do an iteration with the dev, and the dev says what he or she can do or can't do. They go back and forth until they've agreed on what the two specs are going to say and how they're going to look. And then you start writing code. Sometimes the PM can prototype the end result in the form of a mocked up tool. Sometimes the dev just gets to it and starts pounding out code. Regardless, it's a very tedious process. There's a lot of back and forth, which there also is when you use the model first approach. But failures are caught late when you use this approach. And it means a lot of work can be undone, which also means a lot of time is wasted doing stuff that shouldn't have been done to begin with because you didn't realize you were going down the wrong path until you started testing. Anyway, so this approach is still being used in a lot of places today. PM, dev, and then you start writing code, and then you go back and forth. No, this is not what I wanted. Oh, but we agreed on, familiar story, right? So eventually everything's stabilized. You start doing the real testing. You test until you decide with all the iterations that, okay, looks good enough. Let's make the go, no-go decisions. Are there any errors which are so bad we can't push this thing out, or is this a good enough compromise? And then you start to ask the big questions. Is everything okay? Should we push this live? Hopefully, it'll be, oh yeah, let's do this. Most of the time, that's not what happens. Most of the time, what you hear is, no, we really need to fix this. So you start the loop all over again. Eventually, though, you get to the stage where, okay, out of the 29 really, really serious bugs, you've fixed 27 of them. 2 bugs you're not going to fix, they'll take too long, so you simply pull those features out. And you come up with a compromised design, and you're ready to go to market. So, yep, all right. Now it's time to do the fun stuff, write the documentation. Oh boy, that is not easy. It is not fun. And a lot of the time, by the time you're ready to write documentation, the dev spec and the PM spec don't match. And I know because I was a technical writer for 11 years. It is the most unfun thing to do when you're trying to write documentation for something that's going to be released and the specs don't match. It takes a lot of meetings, and then you eventually get to a stage where, yep, they're both saying the same thing. Then you have your tech reviews and everything. And the process is very refined at Microsoft. It's a tried and tested method. Microsoft has been around for many years, so this is a tried and tested approach. Regardless, you spin a lot of cycles, especially when you get to, if I can find my laser. Anyway, especially when you get to the stage where you started doing some testing and then some changes come in at the PM spec level, and you have to start this process over again while somebody has started writing the documentation. It can be quite entertaining, but So here's a different approach. Well, the model first tool says, well, how about we start with a model? Well, how do you create that model? You use JSON or YAML. You use some scripting language to describe the structure you want to end up with. And because of the way the tool is set up, while you're describing the model, the tool is generating stubs that represent the code that you're entering into the interactive portion of the tool. So you're creating your model by writing your scripts. The tool is creating the little stubs. So you have, maybe you start with a parent node called books, and that's it. So what you see in the window that corresponds to where you enter the code is a little node labeled books. If under that, using your model or modeling language, you have 2 subnodes, name of the book, name of the author, and then, I don't know, date released. Well, it will be reflected in the stub because underneath the parent node books, you'll have subnodes which represent the 3 subnode names that you entered into interactive side. So you can test as you go along, because when you use the language to represent the model, you immediately see the result. And if that's not what you wanted, you correct right away and then continue. So you make corrections as you go along. All right, so you keep doing that until you're happy with what you've ended up with. And then the dev starts writing code to implement the model that you've established in the tool. Devs write the code because at that stage the model is fairly solid, and more than likely the only reason why you'll be making changes is because the model, somebody's decided that no, we should add this feature or we should remove this feature, as opposed to making changes because, oh my gosh, what were we thinking? No, this is not going to work. You're making different types of corrections at that stage, because you can test early so you know where you're headed. When you start writing code, the model is fairly solid. So eventually, yes, you have to do some real testing, but all the time you are doing your testing and pounding out code, documentation was being generated. Very much like using annotations in .NET code to create skeletal documentation, which somebody will then fill out. So the tool creates auto-generated docs. They're not very verbose, but enough to let somebody understand what the model is trying to say or do. So, yeah, everything gets to a stage where eventually you have to decide, are we ready to do some real testing? The answer is yes. Yeah, you go for it. And then once again, hey, is this good to go? Over here, more frequently than not, the answer is yes, but for completion, yes, there's a no scenario where you're then required to go through the process again, and then you come to the all-important, all okay question. You make your go, no-go decisions. The answer is yes. You're ready to release, and API and docs can most of the time be released at the same time because you are generating documentation as you were talking. But as I said, it's fairly minimal. So you might have to manually fine-tune it, do a bit of wordsmithing to make some of the terse statements a bit easier to understand. It takes the pain out of creating documentation after the fact, and that's what the Model First tool provides as far as designing, testing, and releasing APIs that conform to the REST specifications. Okay, so the main features are, the fact that you've got the visual rendering of the modeling that you're doing when you're describing your data structure. It uses the Swagger UI. Anybody familiar with Swagger? Oh, okay, one person. Yeah, that's a win. Okay, better than zero. The Swagger UI, and Swagger has been adopted by Microsoft. It's a okay, I won't go into details. So it's a plugin. It's in the form of a plugin you can add to Visual Studio, which allows you to do some of the modeling and scripting for describing data structures and databases. YAML is one of the input formats that you can use for modeling the API. I thought YAML stood for yet another markup language. Apparently, YAML means YAML ain't markup language. So, yeah. Swagger or Markdown is what you get as output. So when you're looking in the window that's visually rendering the information you're putting into the modeling side, it's using Swagger or Markdown as outputs. And this is what the tool looks like. It's free. It's open source. It's hosted on GitHub. You can download, you can clone or download and build, and then just play around with it. There are samples you can use. You select file, and it gives you the option of selecting a sample structure. It will fill the left-hand side with that sample structure. You can add to it, remove from it, and then you'll see the visual rendering on the right-hand side as you make your changes, and that's how you learn how to use the tool. So the Model First tool is this. It simplifies your API design, makes sure that you end up with an API that is fairly solid, as far as what the spec is expecting. And hopefully, we can get you guys to start using it. They can give us feedback and let us know what you think, and then we can all work together to improve the tool. So here's a link to the tool. The input language that I said is YAML. I think it accepts another input language. So it's been updated to accept something other than YAML. YAML is probably the simplest. It was created specifically to be simpler than JSON. And JSON was created to be simpler than XML. So YAML has a really, really short ramp-up time. As you saw, it's easy to understand because of the fact that it was designed to be fairly similar to English, the way you would use bullets to explain something in a Word doc, for example, or a PowerPoint presentation. You have your parent node, and then one line below and one indentation to the right. You have your subnodes. You come out to the same level as the previous parent node. You have your next node. It's fairly straightforward. The only things that you need to learn when you're learning YAML are just little nuances, like how do you represent a collection of books as opposed to just a single book with a title and author, and but other than that, it's fairly straightforward. All right, so these are the resources that point you to the tools and some of the information I used in the presentation. And the goal of this talk, as I said, was to make you aware of the tools that we have, as opposed to going into detail about how to develop your tools or how to take them apart and extend them and all that. If that's what you're interested in, let us know. We'll see what we can do. But otherwise, I want to make you aware of the tools that we have, where you can find them, and do they cost anything? No, they're all on GitHub. So use them, give us feedback. If anybody has any questions, you can ask the MC who embarrassed me by referencing the grass skirt. Otherwise, no, I'm just kidding. If you have any questions, let me know. Otherwise, thank you. My role on the team is I'm one of the program managers who's in charge of managing the SQL Server protocol documentation process. And we make sure that all the protocols that SQL Server uses for communicating with other Microsoft high volume products, Office, Server, SharePoint, all those protocols are documented and they are accurate as far as we know, so that you can read them, figure out how they work, and then implement them and use our tools to check your implementation, make sure they match what the spec says they should be doing. So if you have questions you would like to discuss after the talk, let me know. Or otherwise, so thank you once again. I'm really glad you're here and not asleep somewhere in another room. Thank you, guys. All right.